So up until now, you've been finding your trig function values by plugging them into your calculator and rounding. Now we're going to be looking at finding the exact value. Obviously, the exact value is going to be more valuable than the rounded value because, well, it's more exact. So before we get into that, you definitely need to know all this info right here. So write it down, put it on your fridge, and study it every time you go make a sandwich. So you will never forget it. Okay, first off are these special right triangles, which you may recall from previously in your math career. This is a 45 degree, 45 degree, 90 degree triangle. The side ratios are always 1 to 1 to square root of 2. The hypotenuse is being the root 2. The 30, 60, 90 triangle always has the ratios 1 to 2 to the square root of 3. The 1 is always across from the 30. The 2 is the hypotenuse, and the root 3 is always across from the 60. As another note, when you have radian measures, a pi over 6 radians is equivalent to 30 degrees. So whenever you see pi over 6, you're going to be thinking of your 30, 60, 90 triangle. Whenever you see pi over 4, that's equivalent to 45 degrees. You'll be thinking of the 45, 45, 90. And whenever you see a pi over 3, that's equivalent to 60 degrees again. You'll be thinking of the 30, 60, 90, only 60 degrees will be your primary angle. There are 3 simple steps to finding exact values. First, find your reference angle. Second, draw a right triangle with the x-axis. And third, label the sides of your right triangles. Following these simple steps will make it so easy even a 5-year-old could do it, assuming that 5-year-old is a genius. Okay, let's go ahead and find the exact value of tangent 135. 135 degrees is going to be about right here. Next, let's go ahead and find our reference angle. Our reference angle in this case is going to be 45 degrees. Now this is how you draw your triangle. I'm just going to go straight from my angle here right down to the x-axis. I know this is going to be a right angle, and this here is going to be 45 degrees, because remember they all need to add up to 180. Alright, to label our sides here, I see that this 45, 45, 90 corresponds with this triangle right here that you've put up on your fridge, this 45, 45, 90. So if I label my sides, I know that this side is going to be 1, this side's going to be 1, and this side's going to be the square root of 2. Now let's keep in mind here, we are on a coordinate plane here, and this is the negative x-axis, so this is actually going to be a negative 1. And this is a positive y-axis up here, so this will stay positive. And of course, our hypotenuse is also positive. Now looking at my triangle here, let's find the tangent of 135 degrees. And our 135 degrees, remember, is going to be taken from our reference angle 45. So if I want to find tangent here, tangent is opposite over adjacent. That's going to be negative 1. Boom. That's 1 over negative 1. I just simplified to negative 1. Keeping our triangle here, of course, we could find any other trig value we wanted. Sine, cosine, tangent, secant, cosecant, or cotangent. Let's try one in radians. Here we have secant 11 pi over 6. After I find out where my angle ends, it's going to be right over here, and I'm going to have a reference angle of pi over 6. So I'm going to draw my right triangle here. Now let's keep in mind, this pi over 6, let's look up at our radians here. Pi over 6 is the same as 30 degrees. So to make this a little easier on myself, I'm going to see this angle as a 30. This is going to be a 90. This is going to be a 60. Let's use our 30, 60, 90 to label our sides. Across from the 30, I'm going to have a 1. Across from the 60, I'm going to have a square root of 3. And my hypotenuse is going to be 2. Here I'm on the positive x-axis, so this is going to be positive. Here I'm on the negative y-axis, so this is going to be a negative 1. And my 2 always stays positive because it's the hypotenuse. Secant, remember that's the reciprocal of cosine. That's going to be hypotenuse over adjacent. So that would be 2 over the square root of 3, which if we rationalize that, times root 3 to the top and bottom, that'll give us 2 root 3 over 3. Again, we could find any trig value once we have our triangle. Alright, Last thing, it's been quite a lesson, I know, but I could feel you getting smarter from here. So hang in there, and this is really important stuff. So try to follow along. Try to really get this in your head. The last thing I want to go over is a special case. What if our angle ends on one of the axes? For example, what if we wanted to do 90 degrees? We can't draw a triangle with the x-axis because it would just be a straight line. So when this is the case, just give yourselves kind of a point that would be possible on this axis. So for example, let's say here we had the point 0, 1, right? This might be the point 0, 1, and we've got a line here. Now let's go back to our x, y, r way of thinking. Here the x value is 0, the y value is 1, and our distance r is going to be 1. We can use this to find all our trig values. If we had a point over here, let's say we had the point -1, 0, right here our x would be -1, our y would be 0, and our r would be 1. Again, we can use these values to solve from there. If we had a point down here, that might be 0, -1. If we had a point over here in the positive x-axis, we might have 1, 0. So if you ever get the situation when you land directly on one of the axes, don't try to draw a triangle. You'll drive yourself crazy, trust me. And go ahead and just give yourself a simple point. A distance of 1 is easy, always. So x equals -1, like this case. Over here, x would equal +1. Up here, y would equal 1. Down here, y would equal -1. And then just go from there.